Hi guys, in today's class, our topic for today is derivative of inverse trig function. Derivative of inverse trig function. So now, given this question, show that dy dx of sine inverse of x equals to 1 all over square root of 1 minus x squared. And this one of the GPA questions. This is one of the first questions. So please stay informed. Just follow up. Look at what I'm doing. Our aim of this calculation is for me to show that this man is equivalent to this man. So let's take the calculation. Solution. Let's take the calculation. Solution. Remember, this is dy dx. That means this function is defined in terms of y. So that means y equals to what? Sine inverse of x. Y equals to sine inverse of x. That means you say take the derivative of this, then show that it is equal to this man. So please follow up. Look at what I'm doing. Y equals to sine inverse of x. Invariably, I can say that x equals to what? Sine y. In the other way around, I can say that x equals to what? Sine y. And if you look at this function, this question, if you look at from here, when solving this, you apply an implicit method. Solving this, solving implicitly. Solving implicitly because I'm having x equals to sine y. So I can choose my own method. I can choose to use implicit method to solve, or I can choose to use dx dy that is defined in terms of x over dy, or I use implicit. But for today's class, I will apply implicit method. Stay informed in our next class, then I will use the other method. So now, let me apply implicit. So now, implicit method. Please remember, when you are applying implicit, we have types of derivative. We have implicit function, we also have explicit function. In explicit function, remember, we always define y in terms of x. That means, for example, now you have something like this: y equals to 2x plus 1 x. This is explicit function because we're having y equals to x is at one side. But now this one, we're having x equals to sine y. You can use explicit, but at the end you take the inverse. But now the simplest way, just simply use an implicit function. Use implicit function for shortcut. Don't waste your time. Use implicit function. Differentiate this one implicitly, this one implicitly. Remember, when you are differentiating implicitly, when you are applying implicit method, what do you do? Whenever you are differentiating y, remember you multiply the y dx as the senior man. Whenever you are differentiating y, multiply the y dx. So now, let's take the derivative. If I differentiate x, I'll have y equals to. If I differentiate sine y, I'll have cos y. Then I'll multiply my dy dx as the senior man, dy dx. Because it is what? Implicit method. I'm using implicit, and then I'm differentiating in terms of x. Whenever I'm differentiating in terms of x, then when I differentiate y, I must multiply the y dx. Whenever I differentiate in terms of x, when I differentiate x, I will not multiply the y dx. But when you differentiate y, remember, the y dx must go. So now, from here, I'm looking for the y dx. So I'll quickly make my dy dx something from one. I have to divide it by what? Cos y. So now this man will cancel this man. Take it. I'm having that dy dx equals to what? 1 over what? Cos y. So now, I'm having that dy dx equals to 1 over cos y. But the question says, show that this man, which is this man, is equivalent to what? This man. For you to show that this man is equivalent to this man, please remember, quickly recall. Recall that from trig function that we have that sine square y plus cos square y equals to what? 1. Because the reason why I'm using y is that normally it's supposed to be sin square theta. But the reason why I'm using y is that because my function is defined in terms of y. So I need to use y. Yes, whenever you are using this, applying this, please, to avoid mistake, look at your function. If your function is theta, let's use theta. But if your function now is y, you apply y. So now, I'm having that, I recall that sin square y plus cos square y equals to 1. From here, look at this man. You are having that dy dx equals to what? 1 over what? Cos y. That means, what I will solve here, what I will solve here is what? Cos y. Because here I'm having cos, I want to eliminate this cos y. Our aim is to eliminate this cos. When applying this one, you eliminate cos y. So what do? I quickly make cos square y subject formula. So if I do that, I'll have that cos square y will now be equal to 1. I'll take this one to this side. 1 minus sin square y. Cos square y equals to 1 minus sin square y. So now, I'm looking for only cos y, not cos square y. Then if I take cos y will now be equals to square root of 1 minus sin square y. Because I'm looking for cos y alone, because here is cos y. So for me to do away with this square, I'll take square root of both sides. So when I take square root of both sides, the square root will cancel out, then we have only cos y. So from here, you have 1 minus sin square y. And remember, you have to show that was one thing. So now, I'm having cos y equals to 1 square root of 1 minus sin square y. And from here, come back to this one. You have that what? X equals to what? Sin y. So, but here, I'm having what? Sin square y. That means I can say that cos y equals to what? Square root of 1 minus from here, x equals to sin y from there. So invariably I can say that cos y equals to square root of 1 minus x, because here is square, I'm square it. And what I'm solving is this man, I'm solving for this man cos y. Because if you look at my solving, a is cos, I'm making cos of the formula. So if you look at, I'm solving for this man. So now our end of at the end, we are having that cos y, this man, the result is cos y equals to what? Square root of 1 minus s squared. So I can say that by dividing x, d3 divided x equals to 1 all over cos y in the root of this man in the root of this all over 1 minus s squared and the 2. Thank you very much. This is the name of our class. Please remember, I still remain your instructor. Follow up, stay informed, so that in our next class we look at some other inverse